First of all, I would like to thank very much the chair and as well GraphCom for the invitation. I'm more or less peripheral to this field. My research work has to do mainly with ceramics and composites. However, it does touch a lot of the work that we've done doing in graphics arts, especially in printing, because ceramics are in fact what the pigments are made of, and composites is what you do every day when you're printing. When you print with latex, essentially what you're doing, you are printing with a composite material that's made of ceramic powders, it's pigment, in a matrix, a polymer matrix. And this is exactly one of the things that we're working on. And so I felt very, very comfortable being here. But what I'm going to talk about is not research, but it's actually everyday things that we should be looking at whenever we are producing products for the public. Products that have to be safe and have to be adhered to certain standards. And so the talk will center on the compliance. I think I promised that I was going to speak in Greek, but do you mind if I continue in English? I don't think any problem. Okay, great. Because the whole work is written in English, so it will be simple. So the compliance of not only the printed materials and the products and the inks as well, but it's actually the finished product. The reason that the compliance is necessary at all stages is because when we are coating a material, for example, a paper or a plastic or a PVC or something like that, with a coating, with a printing or any type of material, its properties will change. More often than not, the properties will be different from the original raw materials. So even though, for example, the substrate may be safe, but coated substrate, which essentially what you're producing is a printed material, a printed product, may be different. So it has to be checked. One of the things that I've done in the past, we've done a lot in the past in my laboratory, is actually to check final products, final materials. And you'd be very surprised to see that even metallic substrates behave very differently when you coat them, and you're coating them with a material that's supposed to be completely safe, that's supposed to be completely standardized, and yet the substrate and the coating combination do make things different. So there you are, a most important value-added parameter. That's the essence, the main idea of what I'd like to leave you with at the end of this half an hour. I'll try to be quick. But essentially that the compliance, which of course adds a certain cost to the production, compliance with the international standards is actually a value-added parameter. It's something that is very important both from the point of view of the standards, but also from the point of view of marketing, of the sales, of the end of the user safety. So why is compliance absolutely necessary? Well, first of all, the regulations, and everybody knows about the regulations, REACH regulations, but REACH actually doesn't only cover raw materials. REACH actually covers products. The final thing, whatever is at the customer, will be sold to the customer. Responsibility, that's very important. Both of these 2 points over here have to do with the manufacturer responsibility. So compliance has to be absolutely proven, not only at the level of the materials, inks, substrates, as I said, but also with respect to the products. And when it comes to any damage, let's say anything that might have happened, a fire, because very often the safety standards do refer to the fire. The actual proof of compliance is actually with the seller, with the manufacturer of the product. And of course, at the end of the day, these are the important things, the regulations, but at the end of the day, you have competitive advantages. There's a lot of producers, a lot of manufacturers of products, of printed materials, that do not mention any compliance, do not mention any testing or anything like that. And it's quite, it happens. But at the end of the day, having the testing, having the proof of compliance is going to be something that will give you an advantage. So it's a good indication of superior quality. And of course, it can be used and it should be used. Earlier on we saw a lot of the presentations, and on one of the corners they mentioned eco-compliance, eco, etc., etc. By the way, ECO doesn't necessarily mean compliance, complete compliance. ECO may be a particular compliance with respect to compliance with respect to ecological, environmental impact. But there's lots of other things that we'll be looking at. So there's three. First of all, there's standardization. How do you, when we're talking about compliance, we always talk about standards or following some standards. And there's three different types of standards. It's the international standard, the accredited standards. You probably heard of all of them: ISO, EN, ASTM, DIN, and etc., etc. But then within each industry, there are certain standards that people usually follow, specification standards. And thirdly, within each particular factory, there may be internal standards. And the idea for that is that you go from the third one, internal standards, to the industry standards, and then make sure that at the end of the day, having followed this type of levels, you'll be able to comply with the international standards, which is usually what's accepted, of course, internationally. Without going into a lot of detail, most of you know about these things, of course, but the important thing here is that the provision of the standard or the compliance is proven by following specific use of the standards, of how you carry on the testing, rules, guidelines, and characteristics to carry out the particular testing of compliance. Of course, ISO, you all know, International Standards Organization, that's most of the international standards, but a lot of people, ourselves included, we use a lot of the ASTM standards because they are very specific. American standards, ASTM is American standards and for testing materials. And they are actually used worldwide, and of course, as long as you follow some standard, some accredited standard, then you're fine, and you need to be able to prove that. The industry standards is things that you do as an industry, industry-wide, within the same sector, for example, and sometimes they're limited by design, and this allows inter-industry comparisons if you want to be able to develop something as an industry within a number of companies together. Of course, the market needs and demands very often will change things, so the standards may become stricter. For example, in the automotive field, standards, international industry standards are very specific. They do change all the time. Every 6 months there's updates, there's improvements, there's enhancements, etc. The company internal standards are the ones that emanate from the industry standards, and essentially what you're doing is that you're continuously testing every new thing that you try out. So whenever you're trying new ink, it's always worthwhile on a substrate, it's always worthwhile doing the testing and making sure that the compliance is still valid as far as particular areas are concerned. And of course, these things will follow the industry, the needs of the industry, and that's why I change without notice. I'm sure you've seen a lot of products that do specify these, and they do say that yes, it complies according to such and such flammability testing or something, but the material itself may change. This change can be declared, but the best thing to do, of course, is declare it and test it. Okay, so production goodness standards is what I was talking about in this area here, but it repeats what I've just been mentioning, that new sectors often utilize previous standards for properly related materials, because people have asked me, well, how do we know which standards to follow? Well, essentially what you're doing is you're looking at related sectors, and you're trying to develop either the internal standards to be able to follow that. For example, companies in your area have come back to me and said, well, which standards should we test according to? And how do we classify? Classification is very important, because when you're talking about flammability, when you're talking about dangers, you need to be able to have an international classification. How on earth do we compare? So the international classifications in your area, you'll be surprised, it actually doesn't exist. You will see in a moment that printed materials go according to the building code. So your materials are actually classified according to as a building, materials that are used in building. And that's important, because that ties in with the dangers or with the possibility of, if it's not tested as a compliant, then of course it ties in with the possibility of being held responsible for that. So I think the whole idea of a quality assurance system does automatically assume that testing of materials, products, and everything has been done or they can be traced to a specific compliance test. Okay, you know about regulations and the ISO standards. Those two actually very often are tied in together because EN regulations very often say, well, we do certify this according to EN because it has been proven to be compliant with a number of international standards. And of course, certain countries still retain independent standards irrespective to the EN. So you do find some small changes between countries. Germans, for example, have got because of the build-up over the previous decades, hundreds and thousands of standards, and some of them do not find themselves to be equivalent to the ISO. But nevertheless, depending on your market where you are, where you're selling, you probably will need to be able to check that your compliance is compliant in that country as well. A lot of the ISO have equivalents in the ASTM standards. Up to, well, approximately now, most of the ISO have got equivalents in ASTM. ASTM has developed earlier than most of the rest of the world, together with British standards. So they do have a lot of details. They are being updated continuously every few years. Most standards have been updated because new techniques come into the production, etc. Now, it is important to understand that the standards are not obligatory. You don't need to have compliant standardization. But it is important from the point of view of sales, of actually making development to the public. And of course, do allow, testing allows for a fair comparison and measure of quality, as I said at the beginning. So companies, the actual companies, the customers may demand EN standards, and very often companies, if the supplier, the manufacturer does not offer a compliance certificate or compliance test report, they do come to us and say, well, you know, we're supposed to sell this. We ask the manufacturer, can you test it for us? And we have hundreds of different tests that we carry out, depending on the material, depending on the area, on the sector, and stuff like that. So as a research laboratory, that's why I think Lucien was alluding to, we do a lot of research, but we also do a lot of tests for many different companies. And a lot of companies, actually customers, come to us because of that. Okay, so let's go a little bit more in detail now. I guess one other important aspect is the United Nations regulations regarding transporting. Okay, anything that will be transported, and even, for example, the covers, the PVC covers, the tarpaulin on trucks, they have to actually be regulated. They are regulated according to the United Nations regulations, and it's called the Manual of Tests and Criteria, parts 1 to 3, and anything that may be dangerous. So, for example, we are given a printed tarpaulin or a printed material that we have to test according to the United Nations. It's a huge book, about 500 pages, and there they include standards of testing that do not exist under ISO or ASTM or something like that. So that's another important regulation. For example, anything flammable, any liquids or anything that perhaps the inks that have been printed but they have not been fully tested. So those test a lot of these things, including toxicity of the combustible products. That's another very important thing. You probably have heard about the situation where a furnishing or a wall covering caught fire, and the fire itself went out very quickly, but unfortunately because of the material, the smoke was very toxic, and that caused a lot of problems. So again, these type of things are very important. You'd be surprised how many materials in our homes are actually explosives. So you know, a lot of the things are one has to really be very careful of these things. Okay, there you go. So fire safety, let's go and do a little bit more. I hope I'm going right with time. Lucien, please give me a buzz. Fire safety standards in printing, the most important things are the combustibility and flammability. Combustibility is whether it catches fire, if something is able to catch fire. And flammability is how easy the fire spreads or increases. The measurement, so it's the rate and extent of propagation is important, and whether any ashes or molten droplets can actually cause a secondary fire. Flame sustainability after removal of source, if you remove the source, let's say you put out the original fire, is the material, can the material restart? Is it reflammable? A flash point of any liquids, and then auto-ignition, of course, is very important. A lot of the original inks, a lot of the inks nowadays with water-based, they don't have this problem. However, if the water evaporates, the remainder, it can still be flammable. There are inks like that, so we have to be very careful. Somebody was actually asking me about this earlier, that certain inks, when they do evaporate, they could become flammable. So of course, auto-ignition is important because in a certain temperature, auto-ignition means that if the material is in a 300 degrees, can it catch fire? We need to understand these things. A lot of these things are United Nations regulations. And of course, fire retardants are used everywhere, and used in many areas. They should be used, but the effect has to be re-established if fire retardant is added afterwards. So for example, you might have a paper that has been treated with a fire retardant, and then you apply ink, you apply varnish, then you have to apply another fire retardant because the effect of the printing may have damaged or influenced the inflammability due to the fire retardant. Toxicity, I'm not going to go into a lot of these things, but as I said earlier, the toxicity could be raw materials, inks, products, etc., etc. And most importantly is the product combustion. It's the gases, the smoke, and things like that. Chemical reactions with the surrounding environment are very important because the surrounding environment may have, especially in production, may have actually some vapors that may cause problems. So in the European Union, you have a number of committees. I'm not going to go through this. I understand that Lucien is actually involved in one of those committees, correct? And so he'll be able to give us a lot more information. But the number of committees, and some of them are, all of these committees, they continuously update and enhance a lot of regulations that are going through. REACH, for example, I don't know if you've seen the MSDS, the material safety data sheets. They keep on getting updated whenever necessary.
And harmonized also.
I'm sorry?
And harmonized.
Yes, harmonized is very important between countries, between states. Yeah, that's so. In other words, if you're exporting, you need to understand that compliance in Greece will still be valid with respect to the compliance expected in Saudi Arabia or whatever it is. The harmonization is terribly important. Of course, all these things, they assume that there are expert testing laboratories. In Greece, unfortunately, there's a lot of laboratories that are missing. There was a metrology institute that unfortunately closed down. But so we have started this business, this work, these services, because in order to carry out and cover their needs. So let's just go through very quickly on some of the case studies. Combustibility, as I said earlier, is this capability to ignite, where the flammability indicates the propensity to burn, how easy it is to burn and everything. The most important thing that people care for is the flammability, and this is what essentially is tested. Most of the time that's what people are asking us, auto-ignition, flammability, etc. And as I said in the beginning, it's very important to remember that your materials, the printed materials, are actually classified as building materials. The classification then of the flammability of the products of flame, etc., are according to the building code. And that can be very strict. You need to take that into account. For example, a lot of the new, and I was very impressed by your work, by your exhibition outside, for example, wall coverings. Now those are obviously building materials, but they have to be tested individually first, and then against the cover, against the background that you put it on. So they're building materials. Okay, so there are lots of standards. The most important ones are these ones here. I'm not going to go through them, but there's flammability tests for interior materials. This was originally developed for vehicles and is still used. Vehicles now have some specialized ones. The vehicular industry is very specialized. Then the 635 for plastics and the treated papers, 777, that's both American. Then there's no equivalent in ISO as far as I know, or they're still being developed. EN 1021, that's ignitability by cigarette or match, that's very important, of course. Then you have some plastics for horizontal burn or vertical burn test that has to do with which way the draft, the potential air draft may be coming from. Okay, yes, the classification, as I said earlier, that has to do with the building material classification. There's a German one that's not used so much anymore because it's very coarse. And the EN 13501, that's the very accurate one because it classifies smoke, it classifies droplets, it classifies many different things. And the UL, that's the American one, the UL94, that's for plastic materials. And in classification takes account of all these things, combustibility, melting, smoke production, etc., etc. Okay, I'm not expecting you to read all this, don't worry. It's just the table of classifications, and this is for a particular type of materials that I happen to use this in one of my services that I did. And there it is. There's, for example, you specify smoke production, how many droplets, how easy it is to ignite, etc., etc. It's quite red, of course, here indicates that it's dangerous, do not use. Green is a little bit better, etc. Anyway, the classification is actually bigger than that, longer than that, but we use it as at the end, after we have the test results, then we classify it according to that. Flame retardants, of course, we all know about what that means. The eco label is used for flame retardants for inks as well, but as I said, it's not always. I was very surprised to see a water-based ink that actually increased the flammability of the substrate because it had reacted once the water had actually evaporated. Restriction of use, of course, that's part of the REACH, if I'm not mistaken, regulations, and this restriction of use come out from the classifications. Testing flame retardant printed material. Okay, this I've already mentioned that apart from the flame retardation, the mechanical strength, the UV stability, and physical properties may be affected by the application of flame retardants. So you've got to take that into account. You have to be very careful. It is very important that, as I said before, that the tests must be done before and after. Yes, the materials providers, they do specify the compliance. However, when you are producing a final product, you expected to test compliance as well. And that's flammability testing of inks. Okay, inks on their own, they usually are tested, they're given a certificate with it. Some people actually expect me and they ask me, I've got this ink, it doesn't have a certificate, or the certificate is a country that's not fully accepted in Europe. Is it possible to get a test done on this? And we do flash point recognition, we do a lot of these things. These are United Nations tests, by the way, and United Nations tests are independent of the ISO test. So even if you do have a certificate, ISO certificate, the United Nations regulations for transporting expect you to have the test reports as well from this. And there's more liquids. Okay, I'm not going to go through this. There's different tests we'll carry out. There's a little, this one, for example, there's another one called the oxygen index. Let me come this way before I get a stiff neck. The oxygen index, that's how much oxygen is enough, the minimum is enough to cause combustion of this material. So there's a different test that we carry out. We have a glass tube, this is a sketch, a glass tube, and we actually reduce or change the ratio between nitrogen and oxygen until we get the beginning of combustion. That's quite important because in a closed area, you might find that if there's a draft, you might want to reduce your draft to make sure that the oxygen reduces very quickly so the fire will go up and so on. Okay, there's some case studies quickly, if I can get it down there. This one here is a little GIF that shows that's without flame retardant. It's actually a card that we did some work that we did some time ago. This is according to 11.9.25. And you can see that the flame is already from behind and it's actually burning. There was a flame retardant on the material, but not on the final product, which it was surprising. That's why they asked us to test it. There. Now this one here is the same, but applying a flame retardant on the front surface of the product. It was a printed card, and you can see that the flame retardant has a very good effect. And the fire actually, once you remove the flame, the fire goes out on its own. So it worked. But this illustrated that the paper, it was actually cardboard, so the paper did have flame retardant properties, but once you put the ink on, it changed. So you had to change that. There's another test that's a horizontal flammability test, that's tarpaulin. And this property has been treated with some flame retardant. And essentially what it shows that yes, it is combustible, but once you remove the flame, the combustion stops immediately. So that was well treated. The problem there is that it actually caused a lot of smoke. So the smoke, the amount of smoke developed was very high, and that's why the classification actually specified that there was smoke production, even though the flame did not proceed properly. This is just a small test of what we call the flame sustainability. That once you take the flame out, there's a special this is a very strict construction from the United Nations regulations, and essentially it shows that if you are heating up your ink or whatever material it is, what happens if you are removing the flame? It's the sustainability for a number of seconds, and it's quite a strict classification in the United Nations transportation regulations. This is the stirring, it's a closed test. You have the material inside there, you measure the temperature that it starts flashing. If there is a flame. Okay, this is some of the case studies that I did there. And here they also going to instead of just the safety aspects, but also the quality of print materials, we've built a special UV exposure chamber, which is able to, you can put in seawater, you can actually put in very aggressive conditions, because two or three customers, they came to us and said, well, we want to export to the Middle East, whereas the temperature is 45 degrees, the humidity is 80%, and it's seawater, there's a lot of salt in the air. You know, what are we going to do? And we built our own little chamber. This is UV, okay, it's just showing the damaging. By the way, not all the UV is damaging. You need to be careful. UVC is the low wavelength, high energy UV, and the UVA is the one that's completely safe, but UVB is the one that gives us a nice tan in summertime. And that's UVB is the one that does a lot of the damage. UVC is almost non-existent on the ground at the ground level. And there's a little chamber that we use for very aggressive conditions. It actually has UV. It has extremely intense white light. It's so intense that you cannot put your hand there; you'll burn. And it's rotating. And at the bottom, you can actually put a high temperatures. We can go up to 70 degrees. And we can feed it with seawater. So essentially, you cannot get more aggressive on that. And the reason, and we sometimes do testing of not only of the UV capability of the colors, which was more often than not that's what we asked, but also the material itself, because the material does not last very long under such aggressive conditions. And there's just a little test. And this was accelerated, and we did the equivalent of 4 years, a normal exposure, all together in about 90 days. 90 days exposure, it was equivalent to 4 years, and actually that was a very successful test as far as the customers concerned. It was very happy. I think. Another test that we did that was an unusual test is actually to test the adhesiveness of the varnish, only of the varnish, not of the printer. Now this is a tricky test because you have the substrate, you have the printing, and then you apply the varnish. Now you have to make sure that you don't pull out the printed layer, but you only pull out the thing. So there's quite a tricky test. That's again, it's a special ISO test 2409, and it's called the crosscut test, and there's other tests for the printing. And this is quite a tricky one because it's what the varnish is the most important part when it comes to protection. And there's of course a lot of tests we do for mechanical properties, elasticity of material, if it becomes brittle with UV, etc., etc. Lots of things. We can go down to ambient, we can go up to 250 degrees. Okay, you never see that. But you do get some machinery that does work in high temperatures. So we are asked to do some testing because the metallic surface is actually very hot. And we can go down to very low temperatures, down to, liquid nitrogen, you don't need it, but you can go down to -20, -30, -50. And there's another test This is, yes, there was a test, a self-adhesive, a printed material which was actually self-adhesive on a steel surface. Now that was actually exposed to the sun, and we measured actually that the temperature of the surface of the steel went up to 110 degrees. So we were doing aging of the colors as well as the material itself and the adhesive. And it was quite an interesting little test. We didn't do the full gamut of material testing on this. This is equivalent to sunlight light. It's equivalent to sunlight, and we did accelerated testing over a few days only to find out if the adhesive was going to work. And then finally, just conclusions. Okay, we've already mentioned everything. That the most important thing is really we are able to offer you a lot of these tests that are not necessarily possible elsewhere. I'll do a little bit of advertising of my laboratory, but we have specialist people. We have some very good technicians. We even have a graphics art technical person, which is really good. But the important things to remember is that the testing has to be done before and after. The combination of printing on a substrate can produce different results, and it is recommended that you do tests. They're not expensive, and they are important to do, and especially when anything that will be transported. The United Nations regulations are the most strict regulations because they are enforced, so you do need to take that into account. And I believe that looking at not only what you're transporting inside the truck, but it's also the truck coverage as well. Thank you very much.
Thank you very much. So, thank you, Professor, to pack so much information in 35 minutes when you was required to do it in 25. But
you told me 45.
Yes. But you know, we are always missing time. But anyway, I am impressed by all the information you could convey in such a long time and in an enjoyable day. One remark that I have, and I will give you the mic, don't worry, is that you do some advertising for your laboratory. Please do so. What I was amazed is that you would tell me that you have low temperature, high temperature. I thought you were in Greece and the temperature was always nice. Isn't that true?
Well, you know, if we say a lot of clear
okay, some advertising. But before I give the mic to the journalist that will have a few questions to ask you, there is one thing that I'm very much that I thank you for coming here. It's a very rough subject, you know, and it's not easy to make it enthusiastic that you do. But I want to say that at GraphCom, you will see through the presentation of Panas, they are distributing for many years, many types of materials, and from day one, as far as I know, they have always been very concerned about the fact that it is not harmful for the people, it's good for the customers, of course, but if something is cheap and not achieving what you are expecting, I know that you have removed many times the product. Although we have pressures, you know, from Asia and whatever, I believe that in GraphCom you always try to get the balance between the money you make, but also the danger and the waste that you do. And for this, I think we can give a round of applause to Mr. Vasilis, which is doing that, and to you, you know, for the presentation. Thank you very much. Before I go,